And we're back and better than ever, still in 19-4, where we're dealing with neutralization reactions. In the last podcast, we talked about a technique called titrations, where you can determine an unknown concentration by adding a known amount of base to that unknown acid and performing some calculations. All right? In this next podcast, what we want to do is take a look at another way of determining the endpoint. In the last one, you have to add your base until an indicator changes color, and then you know when to stop adding your base. In this method, you don't actually stop adding base. You use a pH probe, and you simply measure the pH as you add your base, and you get a graph that looks something like this. And then all you got to do is backtrack to figure out when did you reach your neutralization point. Because again, here's your equation. MHVH equals MOH VOH. Typically what you do is you take a known volume of acid. You don't know what the concentration is. And then you add a known base. And you have to know exactly how much you need to get to the neutralization point. Well, in the last one, you simply stopped and read your burette. In this case, what you do is you titrate using the pH probe again, and you go back and look at where it was neutralized. You don't stop at the neutralization point, you look back to it. And where does the neutralization occur? It occurs at a pH of 7. If you take this across, that's your pH of 7. Notice we have a graph of pH on the y and your volume on your x. Well, at a pH of 7, you know you're neutral. So if you take that and take it down to your volume, in this case it's 35.0, that is the volume needed to neutralize your acid. So if we take a look at example number 4, it says, if the curve above was created during a titration in which 50 mils of your HNO3, new acid now, was titrated with 1 molar KOH, new base, determine the concentration of the HNO3, the acid. All right, so quick recap, and then we're gonna solve it. You know how much acid you added. You know, so let me go ahead and write this. This is you add. Okay? You know the concentration of this because this is off the bottle, or on the bottle. And then this, I'll just do it in green because it's at the neutralization point. This is red off the graph at pH equal to 7 because that's when the neutralization occurs. So let's go ahead and do this whole thing here. So once again, MHVH equals MOH VOH. We don't know our concentration of our acid. That's what we're trying to determine. The volume of the acid added, it says it's 50 milliliters, so we'll go ahead and add that. The concentration of our base, it tells us right here. That's what we'll have to do for a test question. Again, only one hydroxide, so therefore it's the same concentration. You get one hydroxide for every one KOH, so they're the same. And now the volume added, we go back to the graph, and we've already said that it's 35 milliliters. At a pH of 7, 35 milliliters of our base was added. So we'll put the 35 milliliters in there. And now solve. Divide both sides by the 50. Cancel those out. And now the hydrogen concentration will equal 1 times 35 divided by 50, and that's going to be 0.70 moles of H per liter. And because there's only one hydrogen for every one HNO3, it's going to be the same. It's a 1-to-1 ratio. 1 mole of HNO3 for every 1 mole of H+. The H+ divides out, and we have 0.70 moles per liter of HNO3. So 0.70 molar nitric acid. All right. So when you're doing these types of calculations with neutralization, they always involve the same equation. But again, you have to read the problem, understand what they're telling you that you're doing, understand what you know and what you're trying to solve for. All right. Now, there are two remaining questions on this page. I think we'll tackle that in the next podcast. In these next two, and go ahead and try them on your own before you get to the next podcast, what you're looking at are bases and acids that have more than one hydroxide or have more than one hydrogen, and so you have to account for that in the calculation. This is much more advanced, so if you're not quite sure how to do this, it's not the end of the world. But for those who are going to be tackling AP chemistry in the next couple of years, this is a type of calculation that you will want to be able to do. Okay, we'll see you next time.